Good morning. Let's have a look at something really old here. That's pretty cool. Now, this is running 2/1000ths out. I would say that could be adjusted pretty close, you know, probably to a couple of 10,000ths. And this indicator is, I don't know, probably 120 years old or more. Now there's something else it does too, and you use these tool makers' buttons. And eventually, I'll demonstrate that when I can get a hold of a 15 to 16 inch faceplate with a D16 mount. I'll find one eventually, but if anyone's got one laying around, send it to me. Okay, I thought you might like that. I'll be back with something else old time, but maybe relevant. Hey, take a look at this. This is more special tool company hand scraping. I'll try some different angles. I don't know, it's hard to see through the camera. I tell you what. They know how to hand scrape there. 1951 is when this machine was made. Now over here, this is pretty cool too. Get some light on it. That's World War II scraping. Like, hey, we got to get this scraping done. But you know what? This machine is an accurate machine. It really is. It's amazing. And at the time, this milling machine was almost twice the price as the old Axelson lathe and that big radial drill. Yeah, this machine without the vertical head was $5,000, and the Axelson and the radial drill were around $3,200. So I suppose with the sliding vertical head, it's got to be at least another $1,000 anyway, so $6,000. And I think the house here wasn't much more than $4,000 in 1940. So that's kind of an interesting perspective if you think about it, you know. So that's cool. But to get the best accuracy out of this machine possible, this is what they did before digital readouts. And a young guy on YouTube has one of these Brown and Sharp mills, and he probably did the wisest thing. He put a DRO on it, and that would make things much easier. But these are Lufkin end measuring rods. And at the time, and actually these are handy to have to calibrate your micrometers, because at the time, this was the most accurate tools and the most expensive tools that these companies made was these things. And they have these set pieces of 2-inch, 1-inch, 2-inch, what are these, 3-inch here, and 4, this one's I can hardly read it, 10-inch. So you can put these together with these exquisitely made 10th reading micrometer heads. And you use these in combination. You can use, excuse me, in combination with a dial indicator that reads in tenths. And once you have stuff zeroed, you could actually set your distance with gauge blocks. And the way these worked, and I'm going to set this mill up for it. I'm on the fence about putting a DRO on it, but I think for fun I'll just set it up with this, and it's probably good enough. After all, I have a jig bore with a digital readout on it, and a good one too. So this here, if I need to get something pretty accurate like that, I think it makes sense to use this set here. And, you know, these sets here are can be found really cheap because nobody uses them. So what you do is set up like a trough, and what would work is like some extruded aluminum, and hook up a fixed stop for your dial indicator. This almost works as a trough on this, but it's just, I don't know. I think I would be better off doing some outboard, and that's what they did on Kearney and Trucker. And a lot of jig borers used these things because the manufacturers couldn't make accurate screws like Moore. Not even the Swiss companies could make screws as accurate as the Moore Special Tool Company, and that's a fact. Okay, so the early mills, horizontal mills, and they had vertical heads and stuff, were really pretty crude. And for quite some time, they were still getting the best accuracy using a faceplates on lathes. And you can really get, if you're careful, near jig bore accuracy. So I'll do that eventually. I found when I'm looking for a tool, it takes a while, you know, and you find stuff when you're not looking for it. Like this milling machine here, I wasn't looking for that, but it was rusted terribly. But I started restoring some woodworking machines that were left out in the weather. And the woodworking guys seem to have a step up on the metalworking guys because I think the woodworking machines got thrown out on the market, maybe 10 years earlier than machine tools, like in the fact that this mill was rusting in a salvage yard, and kind of like the wood crafts industry crashed maybe 10 years before the metal crafts industry. Now there's junk. I won't even go to the salvage yard because it's depressing. Last time I went there, he had like, it was a Japanese-made horizontal mill. It was just like new condition sitting there with the no cover. I think there's a South Bend Heavy 10. I'm sure somebody picked that up. But that's the way it is there. I mean, nobody values the machine tools there. They just go right out in the weather. Take a bunch of old truck tires and stuff. Oh, they're going to get covered. Just the way it is. It's what the value is of stuff. So this was in the junkyard, and now it's in, I guess, my own junkyard. So that's kind of a direction I'm heading with some of this stuff. I think you'll find it interesting. I do. I'm going to do it anyway. There's some more than two woodworkers that have gotten a hold of me that are getting into the metal stuff too, and I think they'll find it pretty nice, and you can start making your own stuff instead of having to buy it. I got into woodworking long after doing machine work, and I tell you what, I got a bunch of old equipment and stuff, but you start buying new stuff, you get nickeled and dimed to death. Okay, well, I'm going to get some things going. I'm not exactly sure. I think the weather's going to get better. They say it is, but it don't. And get on that drill press out there. But anyway, I've got pieces of it I can drag in here, and I got that workbench working, and I just got a lot to do on that. But it's fun kicking around this other stuff too. Okay, I hope you guys have fun in your shop. I really do enjoy this, and it's I'm glad many of you do too, and I can just turn on the camera while I'm having fun. Okay, bye-bye. Okay, so I got this center punch mark here, just off center, see? Let's put this in the collet here. And this is one of those Bowstar collet chucks, and it actually runs pretty true. See if I can get that started. There we go. This is 3/8 oil hardening drill rod. Okay. Let's see if you can see everything. Okay, now this is the little gimbal. I'll put some oil on it. Let me find the pointer. Now, instead of the hooked end, see, this thing's in two pieces. It screws apart. And the hooked end here, I had underneath this piece here. I had a hard time finding something to run out 2000s. But it extended that out enough and gave it a push, and it did. So I replaced the hook end, let me put that back up here, with a center point end. And we'll put that together. You got to watch this end. Look how sharp that is. So I'll put that together. And we'll slide it through the gimbal. Now, the way this works, The closer you have this choked up to the body here, the more movement you're going to get out of it. So we'll put it at kind of a little, have it extend it just a little bit there. Okay, here we go. I'm going to move it. Okay, so I'm going to, where is that? Yeah, it's just about at bottom. This, I'll tell you, the spindle on this thing is not real easy to rotate if you can't get a hold of something. So we'll play around with that a little bit. So the first thing you got to do is bring the tool holder up. I think you can see it I'm doing here. It's fun to demonstrate this old-time stuff. I'm sure they would normally, back in the day, have this, I would expect, in a rocker-type tool post. Okay, now this is what's cool about this tool. Okay, I just got that entering the point right. Now, let me get the light over here. This little body here is spring loaded, so you can push it in. You can see this kind of push out a little bit. Make sure I got that tight enough. Good and tight. I'll push it forward. See that little gap? Now it's under spring pressure. So I'm going to move this and start centering it, and I'm looking at the other end here. So I'm going to raise the tool a little bit, and I believe that'll push it down. Well, let's see if that, I might run out of screw length here. So hold on, it takes both hands. I'll just raise the tool holder. Or I lower it. No, I guess I just lower it. Get a little turned around there. See, it's getting more pointing towards that center. Now I'm going to move the tailstock closer with tremendous strength. Okay, let's see. Drop her down a little bit more. Then move that. Move this closer. Now this chuck here is really accurate. So this is running true, and I'll start rotating it. So I'll stick the key in it, if I can. See that? Isn't that cool? Now I could move it so it's more doing a perfect circle around the center. Let's see. Raise that up a little bit. Yeah, see, I went a little too low. Then you can move the cross slide, see? And it gives you, oh, okay. Well, anyway, what you can do, you can have something on a faceplate is preferable, but also a 4-jaw chuck. You can take and put a center punch mark and drill it, tap it for the toolmaker's buttons. You put a button in there. And then with micrometers and layout, you set up your other buttons on your piece. And then you indicate off the buttons by putting the hook tool in here. This is what they did over 100 years ago. And they made accurate things. And this would be really probably the highest machine technology in the shop at the time for accuracy is this kind of thing. But they could get more accuracy out of the lathe with parts on a faceplate by clamping parts to it. Now, when you're using a 4-jaw chuck, And doing the same thing, you got to keep in mind that you'll start distorting the parts. Okay, we'll go over to this other machine here. Hold on.